Okay, welcome back. Here we are at our trig substitutions, part 3. We want to evaluate the integral of 5 over the square root of 25x squared minus 9. By now, I think you're pretty comfortable digging up a general reference triangle regarding that radical that's in the denominator. So basically, you know that if your leg is a constant, and if we say have the hypotenuse be x, then the other leg is going to be square root of x squared minus a squared, which you're noticing is matching the quantity in the denominator with appropriate x and appropriate a. So let's rewrite the denominator temporarily as 5x whole thing squared minus 3 squared, so that we can kind of see that symmetry of something being squared, something else being squared, and then we can lay a claim on, who's x and who's a. So then by pattern recognition, we know who our x is, and so I draw the general case and then I make it specific to what I'm looking at. So then the variable expression that's being squared is 5x, and then we know who our a is. That's the constant that's being squared, so the a is, by pattern recognition there, 3. And then of course we know our radical expression is 25x squared minus 9. So let me erase that and put it, make it explicit to this case. So root 25x squared minus 9. So now we can lay out the pieces of the puzzle. Secant theta, we want to relate, theta to x and a. So secant theta would be the reciprocal of cosine, and cosine is adjacent over hypotenuse, so we're looking for hypotenuse over adjacent, which in this case scenario is 5x over 3. So we can I had the general scenario written out, but we can make that explicit. So then therefore 3 secant theta is equal to 5x. So I just had those general patterns there, and then, like I said, just make it specific to the case that you're dealing with. Okay? And then if that's true, we can also differentiate with respect to x. So the derivative of secant theta is secant tangent. So we know that secant theta tan theta d theta will equal to equal to 5/3 dx. So, we could manipulate that and call that, we could manipulate this expression and say it in a different way and basically say that 3 secant theta tan theta d theta is equal to 5 dx. Okay? And again, just laying out the pieces of the puzzle so that when the time comes to do all our replacements, we're ready to do that. Okay, let's lay out some more pieces of the puzzle then. Then dx would be, clearly if I wanted to get dx by itself, I'd have to divide by 5. So dx would equal to 3/5 secant theta tan theta d theta. So this is obviously the piece that we're going to need in order to do a replacement on dx. Okay? So let me just highlight this. Clearly dx is going to get replaced with all of this information, and 5x is going to get replaced with 3 secant theta. So let's do all those replacements. And the next, I'll hit pause in the next slide. So I remind you that, this radical, be on the lookout, because this radical really means 5x whole thing squared minus 3 squared, right? I'll highlight it in another color so you can see, okay? What I'm getting at is 5x is going to get replaced with secant theta Yeah, right there. So know that that replacement is going to happen, and know that this replacement is going to happen. dx is going to get replaced with all this. All right, I'll hit pause in the next slide. Let's do those replacements. Okay, I wanted to gear you up for something before the next slide, though. You see this 5 here? And when I do my replacement with dx, notice there's a 3/5 out front. So 5 times 3/5, there's going to be some cancellation. So see, I've replaced the dx while I still have that 5 up top in the numerator. Okay? So what I'm saying is there's going to be some cancellation there. So now we have everything rewritten. So we're going to have the integral. Like I said, this 5 and this 5 are going to cancel. So we'll have 3 secant theta tan theta d theta. So the whole strategy is, to have this sort of pretty integral with respect to theta. You're noticing that in the denominator, I'm going to factor out that GCF of 9, and we'll have secant squared theta minus 1. And then, you're probably thinking, gee, secant squared theta minus 1 is a tan squared theta. So note to self, there's going to be another replacement right there. And you're also thinking that the square root of 9 is 3, right? So we're going to keep cleaning up that integral. And what we're going to do is pull this 3 out front. We're going to pull the square root of 9 is 3. Let's pull that out front. Clearly that'll make a 1. And then at that moment, we'll have secant theta tan theta d theta up top. And down bottom, we just have this expression here that we're replacing with tan squared theta. So down bottom, we have the square root, I'm kind of running out of space there, of tan squared theta. So the square root of tan squared theta is just going to take you back to tan. So I'll hit pause. So I just rewrote it over here. The 3 and the 3 cancel, so we have secant theta tan theta d theta over square root of tan squared theta. And we said we were going to replace this with secant, we said that we were going to replace this, or simplify this with the square root of tan squared. Well, that's going to take us back to tan. So let's go ahead and keep cleaning. So secant theta, tan theta, d theta. Like I said, the square root of tan squared is just going to take you back to tan. So tan theta. And then this cleans up real nice. Tan cancels with tan. And you're left with integral of secant theta d theta. Well, note to self, you don't have to rederive that. That's a known integral. We now know that that's natural log secant theta plus tangent theta. Plus c. And then right at the end, note to self, you're going to have to revisit original reference triangle. So, secant theta from the get-go was 5x over 3. So I'm going to go back to the original reference triangle. See, secant theta from the get-go was 5x over 3. So we'll replace that with 5x over 3. Just kind of noting to self here. And tangent theta, you have to look back at the original triangle. Let's go back and look at it. Well, if you're looking at this original triangle, tangent is opposite over adjacent. So opposite over adjacent. So it's your radical expression over 3. So survey says. So now let's rewrite the final answer. Is going to be, so we had said that the integral of secant theta d theta was going to take us to natural log, I'm just kind of rewriting this again, natural log secant theta plus tan theta plus c. And then we said we were going to replace secant theta with what it was from the get-go on our triangle, which was 5x over 3. And we had looked at our original reference triangle to figure tan theta, and that was root 25x squared, opposite over adjacent, so 25x squared minus 9 over 3 plus c. And like I said, if you make it to here, I'm pretty happy. The author does that extra cleanup, and by now I think maybe you're comfortable with that extra cleanup phase where they, get the LCD, write it as, write the quotient as the difference of logs and combine the constant. So if you take it one step further and say natural log 5x plus root 25x squared minus 9 plus a constant. If you give me this, I'll take that as well. Okay? Hope that helps. And like I said, these problems are going to come at you one at a time on these podcasts because they're so intricate. Good luck.